In section 1.3, we are looking at different types of studies, whether they be experiments or considered observational studies. And one very important takeaway from this section is that in order to have a cause and effect relationship stated between variables, like a response variable and explanatory variable, is that that can only come from having an actual randomized experiment, not from an observational study. We often hear of things in the media of something causes something. This thing causes cancer. We need to be careful to take those things with a grain of salt and see if an experiment was actually conducted where they randomly did everything, or if they're looking merely at data they've observed and trying to link the things in that way. So you can have an association, you can have things be related. That does not necessarily mean that one of them causes the other. So we can have a relationship between two variables A and B, or like a response and explanatory variable, but just because they're related, we cannot necessarily say that there's a cause and effect relationship between them. That only comes through a certain type of experiment being done. So observational studies are those where the researcher observes the values as they exist. They're passive. They're not really interfering or doing anything. Any survey is considered just an observational study. The data I collect from the class is an observational study. In contrast to that, we have experiments. In experiments, the researcher is actively controlling things, at least one or more of the variables, assigning people to groups, that sort of thing. So here are a few quick examples of just looking at, is it an experiment or observational study? If 5 rats are assigned to diet A and another 5 to diet B, and then they look at their weight change, that would be an experiment. The researcher is actually assigning the rats to the different treatments and seeing the effect that that has. So we would be able to get a cause-effect relationship there. If there's a sample of 1,000 people and we find that people who bought a home are less likely to have a Snapchat account, that is just an observational study. For those that are observational studies here, we also want to identify a confounding variable, which is what is a third variable that would be affecting the two variables here, making them not really have a cause and effect relationship. If we're finding that people who bought a home are less likely to have a Snapchat account, it's not that the home buying is related to a Snapchat account in any way. Our confounding variable would be the person's age. Those who are older are more likely to be buying a home and less likely to have a Snapchat account. And then the last one, monthly data for the last 3 years shows that months with more rainfall and La Crosse are associated with a higher number of boating accidents. Here again, we're merely observing how much rainfall, how many boating accidents. We're not controlling that in any way. And so here the confounding variable would be like the season or the temperature. As we look at the months that have more rainfall, those are warmer months, and those are then going to have more people out boating, and so we're going to have a higher number of boating accidents.